Hello everyone. In this video we are going to see how to construct an LALR table out of a canonical LR table. So this is the example that we have taken in the we have seen in the previous video, like construction of a canonical LR parsing table. Like the same example I have taken it with its corresponding table. So here this is a parsing table and these are all the closure set that we form over there. That is I0 1 2 3 4 5 6 7 8 and 9. So these are all the states that we formed for canonical LR states. We have states from 0 to 9 and these are all the productions in each and every state as given. Now with these states, see I have first we check with this reduce operation. When you look into this reduce operation, what happened in I0 it reduced with S dash tends to dot S production, and here in I4 we have C tends to D dot production, and again in I7 we have the same production C tends to D dot, but the look ahead is different. Okay, when you compare this I4 and I7, it both is reduced with the production C tends to D dot, but the look ahead of this place is A and D, and here it is dollar symbol. So these two states have similar production, so we can combine these two things when you combine these look ahead. And again when we check into here, this 8 and 9 state we have the same production, C tends to AC dot and C tends to AC dot, both are reducing with the production number 2, and again the look ahead is different over here again, so we can combine these two states together. Okay, and again when you just check this state 3 and 6, state 3 and 6 it is a shift operation, there is no reduce operation over here, but still the production is same. We have same set of production in state 3 and state 6, but we have a different look aheads. So we can combine these states, but while combining the state we have to check whether is there any clashes over there or not. For example, when you want to combine the state 4 and 7, state 4 and 7, here we have a reduce with production number 3 in A and D, and here we have reduce with production number in R3. Okay, so when you combine these two things together, it's not a problem, right? There is no shift reduce conflict or reduce conflict occurs over here. And again when you combine 8 and 9, here it is reduced with production number 2 in A and D, 8 comma A and 8 comma D we have reduced with production number 2, and in state 9 9 comma dollar we have reduced with production number 2. The remaining spaces are free over here, so when you combine these two states we don't have any clash over here. Okay, and similarly we can check for these two states, that is state 3 and state 6. So state 3 is over here and state 6 is over here. When you want to combine these two states together, here we have S3. Okay, here it is S3 and here it is S6, and we are planning to combine this 3 and 6 together, so it will be two same states, so it is not a problem. And here it is S4 and S7, so this 4 and 7 we are planning to combine it together, so it will be again we have the same. And again in this reduce operation, like 3 comma C you have 8 and 6 comma C you have 9, and again we are planning to combine this 8 9 together, so none of the conflicts are going to occur over here when you combine all the states together. So we can rewrite the table as like we can combine 4 and 7 state as 47, 8 and 9 state as 89, and 3 and 6 state as 36. Now this might be the state in the LALR table where you have states as 0, 1, 2, 3 and 6 combined together, 4 and 7 combined together, and 5, 8 and 9 combined together. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All the states of canonical LR are represented over here, but we have combined two states together. Totally we have combined 3 states together. So now when you are writing the transition, wherever you have 3, write it as 36, 4, 47 and 8 as 89. So 0 it is shift 3, we can write it as S36, and 0 comma D is S4, it is 47. 1 and 2 state remains as it is, accepting criteria remains as it is. So here when you have 6, write it as 36, and 7 as 47, and again you have 6, 36, we have 5 here, and here it is 47, and here you can re-represent it as 89, And here when you are writing the transition, see here reduce operation, we are combining 4 and 7 states together. So it is reduce with prediction number 3, reduce with prediction number 3, and again reduce with prediction number 3. For 7 comma dollar it is R3. So we have to combine it together. And 5 transition is R1, that comes as it is. And 8 transition is R2 in all the places. Right, we have re-represented the table. Now this will be the table for LALR parsing. For this LALR, when you want to parse some input, let us consider an input ADD dollar. When you want to parse this using this LALR table, we have to start from the starting state. So stack contains the start, and input contains the input. Input end with this dollar symbol. So dollar symbol is a special symbol that is used for acceptance. So each time we check inside the table 0 comma A. 0 comma A is S36. S36 actually means we have to shift one element from the input. So A is, it is S36. So we shift one element A to the stack, and we have to make a transition to 36 state. So 36 as it is a state, and the remaining input will be DD dollar. Now we have to check the table. What is 36 comma D? 36 comma D is S47. So S47 is, again we have to shift one element. 36. Next element is D. Shift this D inside the stack, and we have to make a transition to the state 47. So 1 D is removed from the input and it is added to the stack. The remaining element will be D dollar. Now again it is 47 and D. 47 comma D, it is R3. R3 is reduce with the prediction C tends to D. Reduce with the prediction number 3. So like till this handle we have to pop out the stack. So we have a D in this place. So we have to pop out this 47 and D out of the stack. Now the remaining stack element will be 36, and instead of this we have to push this variable inside. Now each and every reduce operation is followed by a go to operation. We have to check what is there in 36 comma C. Always remember that the topmost element of stack should be a state, not a variable or a terminal symbol. So we have to check what is there in 36 comma C. 36 comma C is 89. So we have to make a transition to 89. Getting confused. Okay, we have to make a transition to 89 state. Now the topmost element of stack is 89th state, and the stack contains, input contains D and dollar. We have to check what is there in 89 comma D. So 89 comma D is reduced with the prediction number 2, that is reduced with the prediction C tends to AC. So in the stack we have to pop out all the elements until a handle occurs. So first we pop out A. When it is a state, we'll leave it. Next is C. So the C matches with this, and pop out this 36. And again when you pop out this A, that A matches with this place. Okay, so we got a handle. So we have to pop out all these elements out of stack, and instead of this we have to push this variable into stack. So each and every reduce operation is followed by a go to operation. So go to is, we have to make a transition to 0 comma C. So state 0 comma C, it goes to state 2. So push this state 2 inside stack, and input will be D and dollar. Now the topmost element of stack is 2, and input contains D. So 2 comma D we have S47, that is shift one element from input to stack. So we have to shift this D into stack, and the remaining element of input, remaining input will be dollar, and we have to make a transition to this state 47. So S47 actually means we have to shift one element from input to stack and make a transition to state 47. Now topmost element of stack is 47, and again input contain dollar. We have to check what is 47 comma dollar. 47 comma dollar is C tends to D. R3 reduce with the prediction number C tends to D. So now in this stack we have to pop out all the element until a handle occurs. So until this D we have to pop out this elements. So remaining element will be this Now instead of D47 we have to push this variable C into stack. Each and every reduce operation is followed by a go to operation. We have to check what is there in 2 comma C. So 2 comma C, we have state 5 over here, so push the state 5 in the stack. Now the topmost element of stack is 5 as state. So 5 comma dollar, it is reduced with the production number 1, that is S tends to CC. So in this stack we have to pop out all the element until a handle occurs. So first C you have it and second C you have it. So we have to pop out all these elements out, and instead of this we have to push this S into stack. So each and every reduce operation is followed by a go to operation. So we have to check what is there in 0 comma S. 0 comma S, it is state 1. So push this state 1 inside the stack. Now you have 1 as the topmost element of stack, that is state 1 comma dollar, it is your accepting criteria, input will be accepted. In case if it leads to some other empty column, this actually means that the input doesn't belongs to the given grammar. So that is your error case. So this is how we construct a table for LALR and do parsing in LALR. Thank you.